Hello my dear friends, I welcome back you to my YouTube channel, that is Beginners Chemistry, where you can learn the chemistry in easy manner. In our last class we have studied about the common names. Now common names is very important to start our IUPAC. If you are starting the IUPAC without knowing the common names while you are writing the IUPAC, it will make very difficulty for you. See, if you are seeing this video for the first time, better you go and see the common names and try to remember the common names. And I was given the very beautiful trick to remember the common names. Now by seeing the notation itself, now which is the iso, which is a neo, which is a tertiary, which is a clear, which is a quaternary, already I explained very clearly, and which is a geminal dihalide and which is a vicinal dihalide. Clear? Now that will play very crucial role in while we are writing the IUPAC. Clear? If you miss once that video, once you go and watch it will be in the playlist, and if not, I will give you in the icon and at the end of the screen also. Clear? Now let's start our IUPAC. Now before starting to our class, I just want to give you the quick recap of the last class so that it will be connectivity with this class. Clear? Now if you are seeing for the first time also, you will not have any difficulty. Clear? Here in the last class we have seen about the functional groups, right? Now before going to write before going to start our IUPAC, remembering of these functional groups is very important. Sir, what are the functional groups? Already I explained. And what are that functional group? You have to remember: aldehyde, C double bond OH, ketone, C bond C double bond O bond. Clear? Carboxylic acid, C double bond O OH. Clear? Now you see, this alkane will not act as a functional group, but it is in the form of the organic compound, so we have introduced it here. Then now this alkene means C double bond if it is contained, carbon double bond if it is contained, that is a alkene, and the carbon and the carbon triple bond if it is present, that is alkyne. Clear? Now but these two will not act as a active functional groups. Now from here, whatever the groups we are seeing, they will act as a active functional group. This is amine. Clear? What is a 1 degree amine, 2 degree amine and the 3 degree amine? Already I explained you in the starting video. You can, if you miss, you go and see over there. Next, thiol means SH. Next, alcohol means OH. Clear? Alcohol is different, phenol is different. Clear? Alcohol means ROH. This is alcohol. And the phenol means, for the benzene, if OH is added, this is a phenol. Then next, this is a thioketone, C double bond. Yes. Now the ketone, C double bond O. Clear? Now aldehyde, C double bond O H. Now cyanide, C triple bond N. Next, amide, C double bond O NH2. Now acyl halide or acid halide, C double bond O X. Now ester, C double bond O and R dash. Already I explained what is a R here. R is a alkali. Clear? Now here acid anhydride. Acid anhydride means C double bond O bond C double bond O R. Clear? Now this is acid anhydride. And the sulfonic acid, SO3H. Now carboxylic acid, C double bond O bond OH. These are the functional groups. They will act as a functional group. Clear? Now halogens. Halogens means, already we know, 17th group elements we call it as a halogens. That is Cl, fluorine, Cl, bromine, iodine will never and ever will act as a functional group. They will always act as a substituents only. Clear? Next, NO2 also will never and ever will act as a functional group. They will act as substituent only. Clear? Next, alkali. This R, this is represented as a R. Alkali. Clear? Now the phenyl, this is the phenyl. If without OH, if the OH is not attached here, this is the phenyl. Clear? Now C6H6 is a benzene. Done. From this C6H6, if I was removed one hydrogen, then it will become phenyl. Clear? Then ether. This will never and ever will act as a which one? Functional group. They will always act as a substituent. Sir, what is the meaning of the substituents? Now I will explain. Now you see, This is a IUPAC formula, right? Already I was explained very clearly. What is the IUPAC formula? 2 degree prefix, 1 degree prefix, root word and 1 degree suffix and a 2 degree suffix. What is the 2 degree prefix will say? 2 degree prefix will say about the substituent or branching present in the organic compound. Substituents, just now we have seen, right? These are the substituents. They will not act as a functional group. Now these are the substituents. CH3, halogens, NO2 and which one? Ether. Clear? These will act as a which one? Substituent. Next one is a 1 degree prefix. 1 degree prefix will say about the cyclic ring if it is present in the organic compound. Now bicyclo, spiro. Now root word. Now what are the root word? Now already I explained very clear. If the organic compound, if it is having only one carbon, that is meth. If organic compound, if it is having the 2 carbon, that is ether. If the organic compound, if it is having the 3 carbons, that is prop, 4 carbons but, 5 carbon pent, 6 carbon ex, 7 carbon hept, 8 carbon oct, 9 carbon non. Clear? 9 carbon non and the 10 carbon dec, 11 carbon undec. Now 12 carbon do dec. Clear? Now this is about the root word. Now what is a 1 degree suffix says? 1 degree suffix will say if the carbon and carbon, if it is having only single bond. In the entire organic compound, if you have seen only single bond, then 1 degree suffix will say it as a ane. If in the compound carbon double bond carbon if you have seen, then we can say it as a ene. In the organic compound, if you have seen the carbon triple bond carbon, then we can say it as a ine. Clear? Next, what is the 2 degree suffix will say? What is the 2 degree suffix will say? Already we have studied about this functional groups, right? If any functional group is present in that compound, then that functional group will having the, if it is acting as a substituent, it is having the prefix. If it is acting as a functional group, if it is having the suffix. Clear? Its prefix and the suffix. First we will learn when we start the naming, IUPAC naming for the functional group. Clear? First we will go with the basic, then after that we will give the complex reactions or with the complex IUPAC names also. Clear? Now we'll start with the, first we'll start with the which one? Identification of, first we'll go with the identification of parent carbon chain. For any organic compound, identifying of the parent carbon chain is very important. So this parent carbon chain, I was saying it as a PCC. Then identifying of the parent carbon chain. How to identify the parent carbon chain? Longest carbon chain. Longest carbon chain is known as a parent carbon chain. First of all, if I was given this compound and here we are having the, clear? Now you see, give the numbering. Here itself you have to give the numbering. Now 1, 2, 3, 4, 5 we are having. Now if you choose this as a parent carbon chain, 1, 2, 3, 4. Clear? Now what I said, more number of carbon should be present in the chain, right? So this one will become the parent carbon chain. This one will become the parent carbon chain. Then next, if suppose if they have given in this manner, then how to identify the parent carbon chain? Now if you give the numbering from here, 1, 2, 3, 4, 5. If you go left side, it will become 4, 5 only. If you go right side, it will become 4, 5 only. Both are same. Then if you start the numbering from here, 1, 2, 3, 4, 5. It is also 4 and 5. Clear? In the everywhere you are getting same, right? Everywhere you are getting same. So you can take this as a parent carbon chain. You can take this as a parent carbon chain. If not, you can take the parent carbon chain, this one also. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Clear? Now, next type of the parent carbon chains. Now we'll see. Here, after identifying the parent carbon chain, then we have to give the numbering for the parent carbon chain, numbering for PCC. How to give the numbering for the PCC? Then after that we have to write the names. First of all, if suppose let's suppose if they have given clear. Now this compound they have given, and we have given the one substituents here, or two substituents we have taken. Done? Clear? Now give the numbering. If I start the numbering from here, first identify the which one longest carbon chain. If you start the numbering from here, 1, 2, 3, 4, here it will become 5. This is not the longest carbon chain. Then if you start the numbering from here, 1, 2, 3, 4, 5, 6. Now if you go it here, 3, 4, 5, 6. Clear? But this is not the longest carbon chain. This is not the longest carbon chain. Then if you go the numbering from here, 1, 2, 3, 4, 5, 6, 7, 8, 9. Clear? This is a longest carbon chain. But is this numbering is correct or wrong? Now whatever the numbering we have given, it is wrong. Why? Because now you see here, whatever the numbering we have given, it is correct, but you may get a doubt, sir, why not we can give the numbering from the, you have given the numbering from left to right. Sir, why not you cannot give the numbering from the right to left? So I will give the numbering from here, 1, 2, 3, 4, here 5, here 6, here 7, here 8, and here it is a 9. Clear? Now left to right, it is in the yellow, 1 to 9. Now right to left, it is in the white, it will be from the 1 to 9. So which numbering is correct? Left to right is correct or right to left is correct? To identify that one, now after identification of the parent carbon chain, here this is a parent carbon chain, right? Clear? Now this is a parent carbon chain. This is our parent carbon chain. Now after the parent carbon chain, now these two are the substituent. Other than parent carbon chain, if it is present, those are substituent, right? Clear? Now these two are the substituent. Now which substituent these two are? Which substituent these two are? Now these two are the methyls, right? CH3 bond. Now you can see this is carbon, and here we are having the 3 hydrogens. Here the 1 hydrogen, 2 hydrogen, and the 3 hydrogen. Clear? Now these are the methyl groups, means this is methyl, right? So these two are the methyl substituent. So according to the IUPAC, when you are numbering the PCC, the first point you have to remember, that is substituent should or branching should get least number. Branching should get least number. This is the first point you have to remember. Whenever after identifying the which one longest carbon chain, second point you have to remember that if the branching is present, branching should get the least number. Branching should get the least number. Then now if you give the numbering in the yellow, if you follow the yellow color numbering, branchings are getting 3 and 5. Branchings are getting 3 plus 5. If you go to the numbering from the white color or right to left, now branchings are getting 5 and 7. So what I said, it should what? Substituent should get the least numbers. Or when you add, if the two substituents are there, if you add the numberings of the substituents, should get the least number. That we call it as a locant sum rule. Clear? Now that branching should have the locant sum rule. Lowest locant sum rule it should be there. See, in the yellow you are getting 3 plus 5, it is giving 8. Now in the right to left, in the white it is giving 7 plus 5, it is 12. So in the right to left it is getting the branchings are getting 12. Now in the left to right branchings are getting 8. So the numbering is correct from the left to right. Clear? The numbering will be 1, 2, 3, 4, 5, 6, 7, 8, 9. Clear? In this manner we have to give the numbering for the compounds. Clear? Now next we will see the another type of the we'll take the another example so that it will be clear for you. Here, now here we are having done. Now three substituents are, now which one is the parent carbon chain? Now we have to see. If you start the numbering from here, 1, 2, 3, 4, 5. Done. Next numbering you start it from here. 1, 2, 3, 4, 5. Okay. Done. Now if you start it from here also, you will get the same numbering. 1, 2, 3, 4, 5. Everywhere the numbering is same. Then if you start the numbering from here, from now we have given the numbering from left to right. Now start the numbering from right to left. Here 1, here 2, here 3, here 4, here 5. Now check the locant sum rule. Now substituent should get the least number, right? Now check the locant sum rule. In the red case or left, right to left, substituents are getting 2 and here it is 4, right? 2 and 4. Now here what it is getting? Here also the numbering we are getting 2 and 4. 2 plus 4. 2 plus 4. Clear? Done? Now anywhere the numbering is same. Anywhere the numbering is same. So that the parent carbon chain and the numbering we can give either from the left to right or right to left. Then you will get the confused. See now 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Clear? Now the numbering will be from the left to right or right to left. Then you may get a confused. Then what you have to decide? Here the more the substituents. For this one carbon we are having the more the substituents, right? More the substituents should get the least number. More the substituents should get the least number. You can see here what it is happened. 2 plus 4 plus 4. Here the two substituents are there, right? Here 1, here 1. It is getting 4 and 4. If you give the numbering from which one? Right to left. Two substituents. If you give the numbering from left to right, now the substituents are getting 2 plus 2 plus 4. 2 plus 2 plus 4. Then the overall locant sum rule is 8. Here the overall locant sum rule will become 12. So the numbering will be from the left to right only, not to right to left. So the numbering will be followed 1, 2, 3, 4, 5. Clear? In this manner you have to cross check. Clear? Now next we will go with the another example. With this example, now whatever the misconceptions or whatever the concept you have not understand, it will be clear for you. Now you see, if suppose now already I explained you very clearly about this bond line notation and which one? Bond line notation and condensed form. So every time writing in the condensed form or dash line notation, it will be difficulty for us. So identifying of the which one? Bond line notation is very easily clear. Now you see, first identify the which one? Parent carbon chain and give the numbering so that the substituent should get the least number. So if you start the numbering from here right to left, now numbering will be from the right to left. Here 1, 2, 3, 4, 5. Here it will go 6. But here 6, 7, 8. Done. So here it will be the 6, here the 7, and here it will be the 8. Now you see the where are the branchings we are having? Here the one branching we are having. Here the two branchings we are having. So here the two branchings. Here also two branchings we are having. So give the numbering 2 plus 2 because two branchings we are having. So 2 and 2 we are giving. Plus here 5 plus 5. In the right to left we are having the 2 plus 2 and the 5 plus 5. Now start the numbering from now left to right. Now give the numbering from left to right. If you are giving the numbering from the left to right, here 1, here 2, here 3, here 4, here 5, here 6, here 7, and here it will be the 8. Numbering will be 4 plus 4 and 7 plus 7. 4 plus 4 and the 7 plus 7. So now white one numbering is correct or red one numbering is correct. So red one numbering will be 2 plus 2, 4, and 10, it will be 14. Locant sum rule, we got it as a 14. Now white one numbering 8, 8 plus 14, it is giving 22. So the locant sum rule will be from the red numbering, right? So the numbering will be starts from, now again once again I will write the compound. So the numbering will be from here 1, 2, 3, 4, 5, 6, 7 and 8. Clear? Now this is a correct numbering. Clear? Now we got how to identify the parent carbon chain and how to identify the numbering of the parent carbon chain if the substituents they have given. Now we'll start the naming of the which one? Organic compounds. First naming of the organic compounds. How to start the naming of the organic compounds? To start the naming of the organic compounds, whatever the formula I was given, just you remember that formula. Whatever the data they have given in that, if it is present, make it as right. If it is wrong, make it as strike. Clear? Now how? Now we'll see. First we'll go with the simple example. Just a simple example. This one will go. Now either you give the numbering from left to right and the right to left. Everywhere substituent is getting the same number. If I go the numbering from here 1, 2, 3, 4, 5, substituent is getting 3. If I go the numbering and if I give the numbering from here 1, 2, 3, 4, 5, everywhere the numbering is getting same. So now how to start the naming of this compound? First write the formula. What is the formula of the IUPAC? 2 degree prefix plus 1 degree prefix plus root word plus 1 degree suffix plus 2 degree suffix. Done? Now you see. First one, 2 degree prefix is there. 2 degree prefix will say about which one? Substituent. Now this is a parent carbon chain. Other than parent carbon chain, if it is anything, if it is present, that all are the substituents. So which substituent this is? This is CH3. Now this is CH4, methane. Already I explained you in the common names. From the methane, if I remove one hydrogen, it will become methyl. It will become methyl. This is free bond is attached to the parent carbon chain. Now this free bond is attached to the parent carbon chain. So this group is methyl, right? So this is substituent. Now while you are naming the IUPAC, this notation you have to remember and you have to follow for all the IUPAC. What is the notation you have to remember? First, whenever you are representing number means one or more substituents if it is present, same, then number comma number. Number and number you have to give the comma. Then number hyphen and a letter. Clear? Then letter and letter there should be no gap. These three notations you have to remember and you have to follow. Number comma number, number hyphen letter and letter and letter. Clear? Now you see how to identify this one. While writing the IUPAC, you will be get acquainted. First one, 2 degree prefix is there? Yes. Which prefix? Which one? That is methyl. And which position it is present in the parent carbon chain? Third position. So what I said, number hyphen letter, right? 3 hyphen methyl. Clear? Now, is there 1 degree prefix? 1 degree prefix will say about the ring, bicyclo and the spiro. There is no any ring compound here. Cancel out. Then after that plus root word. Root word means root word will be given to the parent carbon chain containing carbons. Parent carbon chain containing carbons only the root word we have to calculate, not the substituent carbons. Remember. So here 1, 2, 3, 4, 5. 5 carbons means what? I said pent, right? P-N-T. That. Clear? Now, in the organic compound, are you seeing any double bond? Are you seeing any triple bond? Are you seeing any functional group? Clear? No, right? Only all the bonds you are present in the parent carbon chain is straight chain. Clear? Are single bonds only. If it is all the carbon and the carbon, if it is single bonds, then 1 degree suffix will say it as a N. Clear? Now, is there any functional group in this compound? No. So, strike the 2 degree suffix. Clear? Now, combiningly, you write the name. 3 methyl. So, letter and letter, there should be no gap. 3 methyl pentane. The name of this compound is 3 methyl pentane. Simple. 3-methyl pentane. That's it. Done. Now, next very simple compound will go now. Just now we have seen this compound, right? Just now we have seen this compound. So the numbering will be starting from here 1, here 2, here 3, here 4, here 5, here 6, here 7, here 8. Better now only you have started, right? So I will not go with the somewhat complicated. Just simple one will go. Clear? Now this is which one? Longest carbon chain. Now in that longest carbon chain, same thing. Again you write the formula. 2 degree prefix, 1 degree prefix plus root word plus 1 degree suffix plus 2 degree suffix. See, until you get acquainted with the formula, still that time you just write. Now see the substituents first. Which positions the substituents are there? 2 and 5 positions are there. Now already I said you, number comma number. So 2 position and the 5 positions we are having the substituents. So the numbering will be 2 comma 2. Clear? Next you have to represent the letter, right? So you have to represent the hyphen. Done. Then after that, which substituent these are? This is methyl and this is methyl. Clear? But 2 times it has been repeated in the organic compound side. So 2 times if it is represented, we have to use it as a di. If it is 2, if it is 3, try. Clear? Done. Now here 2 times it has been represented, right? Then we have to represent it as a di. Di 2 comma 2 dimethyl. Now root word how many carbon? 8 carbon, right? So oct, and all are single bonds N. 2 comma 2 dimethyl octane. 2 comma 2 dimethyl octane. Clear? That's it. Now next type of the compound will go. Next type of the compound. Clear? Now this type of the compound they have given. Now first identify the parent carbon chain, then give the numbering that substituent should get the least number. If I go the numbering from here 1, 2, 3, 4, 5, 6. Okay. Now if I go here 5 and 6. Clear? Then here also you are getting the 5 and 6, and here also you are getting the 5 and 6. But here you are getting somewhat, if you choose this as a parent carbon chain, this one will become the complex substituent. How to name the complex substituent? I will explain very clearly. If in the question, if they ask with the complex substituent, then you choose this as a parent carbon chain. Then according to the IUPAC name given in the option, you have to choose. If suppose they have given if you have chosen this one as a parent carbon chain, and whatever the IUPAC you got, that if it is not present in that one, then choose the IUPAC or parent carbon chain in this manner. Then if you choose this parent carbon chain, whatever the option you have seen in the question, that will be present. Then if they want to ask in the complex, they will mention it is as a complex. Now if you consider this as a parent carbon chain, now check whether the substituent get the least number or not. Now what the substituent we got? 3, 4 and 5 plus 5. If you choose the numbering from the yellow one, then if you choose the numbering from the which one? This is right to left. If you go it from the left to right, numbering will be 1, 2, 3, 4. Clear? And this is 5 and this is 6. Numbering we are getting 2 plus 2 plus 3 and plus 4. Then left to right we are getting the least number, right? 4 plus 4, 7. Here we are getting 10, 14 and the next one we are getting the 17. So right to left numbering is wrong. Now left to right numbering is correct. Now the numbering will be and now numbering will be from the left to right. 1, 2, 3, 4, 5 and 6. Here now different types of the substituent is as present in our parent carbon chain. This is methyl. This is also one type of the methyl and this is also one type of the methyl. Clear? Two methyls are there. Now this is which substituent? Now already I explained you. C2H6. This is ethane. If you remove one hydrogen from the ethane, it will become ethyl. It will become ethyl. Now this is a ethyl substituent, right? Ethyl substituent. Now here the naming. Here the naming, whenever you are naming the substituent, here you have to follow the alphabetical order of the substituent. Clear? If two different branching is present, now first give the high priority to the that substituent or that branching which comes first in alphabetical order. In the alphabetical order, which one will comes first? For that one we have to give the high priority. Clear? That one we should give the high priority while writing the IUPAC name. Clear? Now here this ethyl is at the 3 position, right? This ethyl is at the 3 position. Now the naming of this compound will be first one. Ethyl is at which position? 3 position. So 3 ethyl. Then after that again you have to represent the another branchings also. You have to represent their numbering. So you have to give the hyphen. Now in which positions that branchings are present? Now 2, 2 and 4. Clear? In the 2, 2 methyl groups are there and fourth position also methyl group is there. So 2, 2 and 4, 2, 2 and 4. How many methyls we are having? 3 methyls we are having, right? Then we are representing the number after that we are representing the letter, right? So we have to use the hyphen. And how many methyls we are having? Trimethyl. Clear? 3 ethyl, 2, 2, 4, trimethyl. How many parent carbon chain we are having? 1, 2, 3, 4, 5, 6. 6 means X. All are single bond. So hexane. 3 methyl, 2, 4, trimethyl hexane. Clear? Now in this manner we have to write the name and the next compound will say. If they have given in this manner. Done. Here they have having the 1 here and the 1 substituent here. Clear? Now here if you choose the parent carbon chain, this one 1, 2, 3, 4, 5, 6, 7. If you go it are also 6 and 7. Anywhere it will be same. If you choose the parent carbon chain, this one also it will be same. If you choose the parent carbon chain, this one also it will be same. Then numbering whatever I was given, it is correct or wrong. Now you see here 1, 2, 3, 4, 5. Right to left numbering will be 1 to 7. Now left to right I will give the numbering here. 1, 2, 3, 4, 5, 6 and 7. Done. Now left to right numbering will be 1 to 7 also. In the right to left substituents are getting numbering 2 plus 5. Now in the left to right, now branching is getting 3 plus 6. 6. Clear? Here we are getting what? Here we are getting which one? 7. Here we are getting 9. So which one is correct? Right to left is correct, or right to left is correct, or left to right is correct? Now right to left is correct, right? Because branchings are getting least number. Branchings are getting least number. Then how to name this one? How to name this one? This left to right numbering will be wrong. Then how to name this one? But here we are having the methyl substituent. Here we are having the ethyl substituent. So according to the alphabetical order, the first which substituent will come, that you have to write in the first, right, in the IUPAC name. So it is present at the which one? 5th number. So this is 5-ethyl and 2-methyl, because E will come first after the M, right? So 5-ethyl, 2-methyl, how many carbons are there? Hepto, all are single bond. So this is heptane. This is heptane. Clear? Now, next with this example we'll go. Let's suppose they have given this one. Then how to name this compound? Here 1, 2, 3, 4, 5. If you choose the parent carbon chain, this one, or if you choose the parent carbon chain, both are same only. Both are same only. Now you see, these 3 positions we are having the substituents, right? This 3 position we are having the substituents. Now 3 position, what are the substituents we are having? Ethyl substituent. Now you see, this is CH3, and here this carbon with 2 hydrogens. So this is C2H5. This is C2H5. So 2 ethyl substituents we are having. Which position we are having? 3 position we are having. So how to name the naming? 3, 3, 2 substituents we are having, and 2 substituents if it is having, so we have to represent it as a diethyl. How many carbons we are having in the parent carbon chain? Hept, and it is all are single bond. So 3, 3 diethyl heptane. Now let's suppose if they have given in this manner, N means here 1, 2, 3, 4. There is no any substituent. All are parent carbon chains only. So how many carbon? But. All are single bond. So it is butane. That's it. Simple. Done. Now this is about the which one? This is about the alkane. This is about the alkane. No. Just now I explained you. If suppose any, which one? If suppose any complex branching, if they have given IUPAC naming of complex branching. If the complex branching is present, in the parent carbon chain, how to write the IUPAC name for it? How to write the IUPAC name for it? For that one, first of all, how to write the complex branching? For that complex branching, we are having the IUPAC name as well as the common name. Both will be accepted by the IUPAC. Clear? IUPAC name is also accepted for that branching one, and common name is also accepted for that one, IUPAC name for that complex branching. See, if suppose here, let's suppose here the parent carbon chain they have given. For this parent carbon chain, if this type of the complex substituent is present, this is the one complex substituent. Clear? Then IUPAC name for this complex substituent. What is the IUPAC name for this complex substituent? Now you see, first you have to identify the which one? What? Longest carbon chain. If you go 1 and 2, both are same. So this is 1, 2, and one position substituent is present. Which substituent? Methyl substituent, and these 2 carbons. So 1 methyl. Now parent carbon chain 2 carbon, 1 methyl ethane. This complex substituent, what? This complex substituent IUPAC name is 1 methyl ethane. Done? No. This complex substituent IUPAC name is 1 methyl ethane. Then common name already I explained you. Here for the carbon, if any free substituent, if it is having the one hydrogen and the methyl, one hydrogen and the methyl, one hydrogen and the one methyl, and if the free substituent it is there, this type of the group we call it as a which one? Isopropyl. The common name will be the isopropyl. Done. IUPAC name will be the 1-methyl-ethane and the common naming will be the isopropyl. Isopropyl. Done. Now in this manner we have to give the IUPAC name. Now I will write the some examples very clearly here. Now we will see. First one, PCC, here the CH, here the CH3 and here it is a CH3. Now IUPAC name will be the 1-methyl ethyl. 1-methyl ethyl. Now common naming will be isopropyl. Common naming will be the isopropyl. Done. This is IUPAC name. Now this is a common name. Anyone we can use. Then next compound, if suppose if they have given PCC and here it is a CH2 and here it is a CH and here it is a CH3 and here it is a CH3, if suppose if they have given, then naming of this compound will be here 1, 2, 3. So this one will be the 2-methyl propyl. Sir, why you are saying this as a propyl? Because here parent carbon chain, one it has free valency, right? Here it is having the free valency and this is a complex substituent. This is a complex substituent. Clear? That's the reason 2-methyl propyl. Name for this one will be the isobutyl. Isobutyl. Done. Now next one, PCC and now here the CH, here the CH3, now here the CH2, now here the CH3. Clear? Now this common name you can see. This one will be the 1, 2, 3. This one will become 1-methyl propyl will be 1-methyl propyl will be the IUPAC name. But common name will be, already I explained you, free valency, and if the carbon if it is having what? Carbon if it is having the free valency and that if it is attached to the two carbons, then it will become the secondary butyl. Secondary butyl. Clear? Now next, if PCC and this carbon, if this carbon is attached with the in this manner, this type of the complex substituent if they have given, naming will be 1, 2. Anytime it will be, anywhere it will be here 1, 2. Anywhere it will be same. Anywhere it will be same. Then 1, 1 dimethyl, 1, 1 dimethyl ethyl. 1, 1 dimethyl ethyl is a which one? Complex substituent IUPAC name. Now here common name for this one will be the tertiary butyl. Tertiary butyl is a common name. Clear? Now you see. So in this manner we can identify the which one? Complex branching, common name and IUPAC name. So I will give you the very important points whenever you are writing the IUPAC name for the complex substituent with the compounds. It will be very clear for you. Just to remember that one I was given over there. First points you have to remember. These points are very important. Important points to remember while you are naming the complex substituent. While naming the complex substituent, these points you have to remember. First one, complex substituents is always written in a square box. In a square box or square bracket. In the square bracket only the complex substituent should be written. So already I said you write both IUPAC and common name. Both IUPAC and common name is accepted. Clear? Now most preferable is IUPAC only. Better we'll go with the IUPAC only. If you are getting the difficulty with the common name, better you go with the IUPAC. IUPAC giving to the complex substituents is not at all a difficulty for you. Clear? Then third one, for complex branching, if more number of branching is present, more the number of complex branching is present, then here we have to more the number of branching is present, then we have to give the di, tri, tetra considered alphabetically. Clear? If two or more same complex branching are present, if two or more same complex branching is present, then we have to use, instead of di we have to use bis, tris, and if it is having the 4, it is a tetrakis. Clear? Now out of the bracket. These are the points you have to remember to write the complex substituent for the IUPAC name. With the examples it will be clear for you. First of all, with a just well-known example for you. If this type of the substituent they have given. Now this is a longest carbon chain. Now if you go the numbering here 1, 2, 3, 4, 5, 6, 7. If you go the left to right and the right to left, complex substituent is getting same only, number 4. So this is a complex substituent, right? Then what is the first point I said? Complex substituent should be represented in the square bracket. Now at which position it is there? 4th position it is there. So 4. Next it is to be represented in the square bracket. Now what is the complex substituent? This one, this is 1 and this is 2. This is 2. This is 1 and this is 2, right? Then complex substituent 1 methyl, 2 carbons means ethyl. 2 carbons means ethyl. Done. 1 methyl, ethyl, and we have to close the square bracket and followed by the parent carbon chain. Parent carbon chain F2, ILR single bond, so F10. 4, 1 comma 1 methyl, ethyl, F10. 4, 1. Clear? Done. Next, if suppose if you want to write it with the which one common name, what is this common name? Now this is hydrogen, and 1 methyl it is present, right? This is 1 hydrogen and 1 is methyl. So 4 isopropyl heptane. In this manner also you can write. So better you go with the IUPAC name only. Next type of the complex substituent they have given. Now next we will go with this one type of the complex substituent. Okay, now 4th position we are having this one. One extra branchings also present. Now you see here, now start the numbering from here. If you give the numbering from here 1, 2, 3, 4 you are getting, 5, 6, 7 you are getting, 8 you are getting, 4, 7 and 8 you are getting. If you started from the which one, right to here, right to left. Now here if you started from here to here, left to right if you start. Now Here it will getting 1, 2, 3, 4, 5, 6, 7. 3, 4, 7 is the lowest sum rule. So this will be the correct numbering for this comp. Then here the substituents are there as well as a complex substituent is also there. Substituent as well as complex substituent is there. Then how to write the naming for this one? Now see the complex substituent is at which position? Complex substituent is at the which one? 4th position. So 4. Now which is a complex substituent? Now give the numbering. Here 1 and here it is a 2. Then represent in the square bracket, right? And here it is 1 comma 1. 2 methyl groups are there. 1 comma 1 dimethyl. 1 comma 1 dimethyl. What is that? 1 comma 1 dimethyl ethyl. Then after that followed by other substituent. Then followed by other substituent, you have to follow the alphabetical order, right? Alphabetical order. This is ethyl and this is methyl. So this is 3 ethyl and this one will be the 7 methyl. This is 3 ethyl, this is 7 methyl, parent carbon chain, how many? 10, right? Then decane. Clear? In this manner you have to write the complex substituent molecule if they have given. If they have given the complex substituent, now you have to write in this manner. Done? Now one complex substituent I will give you. Now try it from your end and comment this complex substituent IUPAC name in the comment box. So this is a one complex substituent I was given. Try to answer this complex substituent name in a comment box. Okay. Now almost we have seen which one. I will give you some questions. Try it from your end. Now this is one type of the complex substituent. Now questions. First one. Second one. Okay, this is 2. Now third. Okay. Now for this type of questions, now listen. If two different types of the substituents if they have given, like the Br they have given, some chlorine they have given. This 2 will not act as a which one? This 2 will not act as a functional group. This will act as a substituents only, right? Then if this type of the substituent they have given, then how to give the naming for this one? If you go the numbering from here 1, 2, 3, 4, 5. Substituents are getting 2 plus 4. If you go the numbering from here 1, 2, 3, 4, 5. 2 plus 4 only. Both the cases substituents are getting 2 plus 4 and 2 plus 4. Then how to identify which one is a correct numbering? Then already I explained you. If two are different or 2 or more different substituents are present, then the naming should be given according to the alphabetical order of that substituent. Now comes to the here. This is bromo and this is chloro. B will come first, right? So bromine should get the least number. If you follow it in the white one, bromine is getting the highest number 4. If you follow in the red one, bromine is getting the 2 number. So red one is the correct numbering and the white one is the wrong. Done? The naming will be here 2 bromo and 4 chloro. How many carbons are there? Pentane. This is a correct naming for this one. Now I will give you the question based on this one. Now try to name the compound. Okay, try to name the compound for this one. Now next, fifth one. Fifth one, mm, okay. No. Now sixth one. Now we'll give the some complex substance. Now this is some complex substituent I was given. Try to name this one. And the seventh complex substituent. Now this is one different type of the complex substituent. Now try to name the this complex substance which I was given. Clear? Now try to comment in the comment section how much or how many you have tried. Just you comment in the comment section so that I get to know, so that for you more the number of content I can give it for you. Okay, now we'll see in the next lecture.